Hi guys, and welcome to another InstaMAT tutorial. This one will be aimed more towards advanced users as we're gonna cover some technical stuff, and it maybe won't be as artist friendly as usually, but I promise it's worth it. So today we will take a look at the nPass element graph, and the nPass element graph is, I think, one of the most powerful features of InstaMAT. And for material artists, it's really worth to learn these workflows to bring their materials to another level. So what actually is nPass? With the nPass element graph, you can build advanced image processing nodes that perform multiple passes and can carry data from one pass to the next. This allows for the creation of nodes that were never possible before. In this tutorial, we will create a node that allows to add random wear to tiles or bricks using multiple passes of the slope blur node. And we also will learn a bit about exposing parameters and visibility expressions. So let's jump in. As you can see, I already prepared something. So this is a simple brick wall material, and as you can see, we have applied some edge wear, and in some areas we have a lot of wear, like here for example, and in other areas the damage is quite fine, like here. And usually when you use a slope blur node, you will get basically constant damage over all of the bricks or tiles based on the noise. Just look at an example. Let's spawn a slope blur node as well as a fractal sum noise. They are here. Let's set up the fractal sum noise a bit. So we bump up the interpolate value, the gamma, and we'll also use custom grain. We bump it up a bit, input it into the height. And we'll take this bevel node and input it into the image input. We'll drag the connection by pressing and holding Control into the output of the slope blur node. And as you can see, we have a bit noisy wear, so we're gonna increase the blur direction a bit. We'll also set the mode to a minimum. And as you can see, the wear on the edges of the bricks is quite constant over all of the tiles. The strength is comparable as well, it's just based on the noise. So where we have brighter values, the damage is a bit more coarse, and where we have darker values, the damage is finer. And with the node we're gonna create today, like you could see, it looks way more believable. And we also have some settings on this node. We can, for example, increase and decrease the pass count. We can decrease and increase the wear amount. The sample count is just the sample parameter from the slope blur, so we keep it at 16 for now. We have different modes for the scale parameter of the noise and the interpolate type. So currently the scale type is set to random. When we set this to manual, we'll get a new parameter, which is scale. And by increasing and decreasing it, we get a bit more control over the effect. Same for the interpolate. When we set it to random, it just uses random values to set the interpolate parameter. And as you can see, when I change this to a manual, we get an additional parameter, and this works with visibility expressions. I'll show you how this works as well. Then we have a soften parameter where we can soften the chiseling or sharpen it up, and also an opacity parameter where we can increase the effect and decrease it. So the material itself, I think it's not really worth mentioning. It's just a simple brick wall. It's based on the brick generator with a bevel and the random wear node, and a bit of applied color and a roughness map. So what we will take a look at today is this one, the random wear node, and as you can see, this is the setup, but we're gonna create it from scratch. So let's press the plus and choose the nPass element graph, create project without a template. As soon as we open the nPass element graph, we are greeted with those two nodes. One of them is the onExecute assignment node, and the other one is the didExecute assignment. So what we need to do first is to create a local variable. We already have one, the pass index, as well as the input pass count. So the pass count is the parameter that will determine the number of iterations. So what we need now is an nPass variable that we call buffer. We can use element image and element image gray. That depends on with what you want to work, either color nodes or grayscale nodes. In this case we need grayscale, so we create an element image gray. We call that one buffer and we drag and drop it into the canvas. So the buffer is the most important variable here. It stores the last pass and can be used, for example, to blend the current pass over the last one. So this is actually where your data is stored. To the onExecute assignment, you can connect an input variable. It's basically the input for the buffer. It will determine what will happen at the first pass. But for this example and this node, we don't need this, so we can skip it. The didExecute assignment is actually what will be stored in the buffer. So later on we will input our result into it. But first we need to know what we want to do. So as mentioned, we want to have a slope blur node which does multiple passes and which will create wear based on random values. And as a noise for the wear, we will use the fractal sum. We will need a bunch of random number nodes. We will need some for float and for uint as well. And those nodes will create random values based on the seed. So as seed input, we take our pass count and we input it into the seed. So when we now use the pass count, you can see that it generates a different number for each pass. We can adjust the minimum and the maximum. So let's take the float as an example. When we use 0.4 as maximum and let's take 0.3 as minimum. And when we'll use the pass count now, you can see that the random number will always stay between 0.3 and 0.4. Let's actually go to the graph variable editor and set the range from 1 to 5. So now the pass count only goes to 5. That's enough. So we have this fractal sum noise, and it's always good to first work with the actual nodes that you think the effect will be applied to. So in this case, the brick generator, as we want the node to make damage on tiles. Let's set it up like so. Let's decrease the bevel and let's increase the gap. Let's prepare it like this. Let's set both to grayscale. Let's input the fractal sum noise into the height. So as the fractal sum is really grainy, we'll need a blur direction on the slope blur node. We'll use the random number float and input it here into the blur direction. And let's set up the node so that we always have a believable looking wear. So maybe between 0.1 and minimum 0.01 and maximum 0.1. So when we check the pass count, you can see we have passes with coarser wear and passes with softer wear. That always depends on the random number that is generated. Let's also use the intensity parameter. So as this is also a float, we'll need one more of those. So let's press Alt and drag it. Let's input into the intensity. And the values for this one are too low. Let's use maybe between 0.6, 0.06 and 0.4. Yeah, 0.4. And we can also always check with the pass count what actually happens. This looks a bit too much. Let's use 0.01. Actually, let's set up the fractal sum noise first, as this is what will give us the damage, the actual damage. Let's set it up like before in the example with gamma and custom grain. The scale and interpolate values are quite nice for the effect, so let's randomize them. For the scale, we'll use the make uvec2 node and this random number uint, so we can input it into the x and y. And let's set the minimum and maximum to, let's use maybe 1 and 4. So this is a quite nice example. Like you can see in the third pass we get a really coarse effect, and in the fourth we get a really subtle effect. This might be too strong actually, so let's use between 2 and 4. Or maybe 4 and 6, or 3 and 6. So this is always a bit of guesswork. It depends on what you want to do. You have to try out many things. The higher counts are not looking as good. So let's take 3 and 1. Let's also use a random number float for the interpolate value. And let's set it to 0.06 maybe, and to 1, or rather to 0.6. Let's take different values here, maybe from 2 to 5. And let's always keep our graph clean. So now we are generating the scale of the fractal sum noise and the interpolate value by random numbers. We can also use the seed parameter in the fractal sum noise. So let's just duplicate this one and reset it to the default values and input it into the seed input of the fractal sum noise. So we also get a different seed for it for each pass. That looks quite interesting already. So in the next step, we're gonna invert this node as we want to subtract this effect from the initial input. And let's also make a blur parameter like I had in the initial node. Let's use a little float and set it to 0 and 0.04. And let's expose this as opacity. Let's right click on the opacity, change UI control type to percentage slider. And when you hover the connection over the expand button, the node will expand and you can just drag it into the input. So when we now use the opacity parameter, you can see that it blurs up. The lerp float node is quite nice as you can choose a value where the parameter will use to set the strength. So for example, this blur node can't go above 0.04, which is 4%. As for example, when we set it to 25% like it is by default, the blur would be quite too heavy. And like this, we have a parameter that goes from 0 to 1, but actually sets this node between 0 and 4%. So now, as we don't want this to be applied over the bricks, like let's show this when I blend this over the brick generator and subtract it, we will get constant damage over all of the tiles. So we need to mask it. Let's use a clouds noise for this and a histogram edit node. For this node, we will randomize the seed for each count, so we need a random number uint again. So as always, press Alt and drag the node to duplicate it. Let's input the result into the seed. And we also want the where amount parameter which we had. This will be the master parameter. Actually, at first, let's just look what the effect is. We set up the contrast and we will subtract it from the slope blur. So this is what will get masked. And it's not enough, so we need to bump up the master slider and the contrast as well. Let's use a high contrast value like 0.87 maybe. And again, we want to lerp it, as when we go too low, we don't get nearly any mask at all. 0.6 looks quite nice. Let's use a lerp float node. Sets the A value to 0.6. And we also don't want to have it all white. So maybe let's keep it at 0.75. Let's input the parameter into the X and the lerp float into the master. So now when we use this, The mask looks quite nice. So what we need to do now, we need the edgeware and we need to blend it with the buffer. Let's take another blend node. Let's input the blend to the foreground of this blend and let's input the buffer into the background. Then let's set the mode to maximum. And this node now will go into the buffer input in the did_execute assignment node. So this is what will actually be saved in the buffer in each iteration. So when we now decrease the pass count, nothing happens. We will need an output node first. So let's expose the blend, its output as output. And I'm just wondering why that's not working, because I made a mistake. As the parameter for as the input for the random nodes, we need not the pass count but the pass index variable. And when we now use the buffer, you can see this is what gets saved in the buffer by connecting it to the did_execute assignment node, and then the buffer will blend over what is generated in the next pass. So this is the first pass, we have a bit of wear, and in the next passes this gets blended with the buffer again and we get more and more wear on this. And now when we, for example, use the wear amount and decrease it, actually we need to invert it. So let's go to the wear amount and let's set 0.75 as A and 0.76 as B, and the parameter will get inverted. So when we decrease the wear amount it gets less, and when we increase the wear amount it gets more. Yeah, and that's basically it. Here we blend it over the initial input, or in this case it's still the brick generator, but we're gonna blend it with the input and subtract it. Then we need to set this into as the output, which is not named correctly. So now we can actually make an output, an input, by pressing on the add input parameter under inputs and use element image gray. We call that input and we drag and drop it into the canvas. Let's set this to this image maybe. Then drag those connections with control into the input. We can delete our brick generator. Let's save this. Let's call it Randomware tutorial. Let's save it again. When we go to our first graph and drag and drop the node from the package management, we can actually use it, and it now applies the same randomware, or basically the same randomware as the node I made before. So when we play with the passes we get more or less. Same with the opacity, I think that's the blur, which we did not name correctly. That's the wear amount. So basically we already created the node we wanted, but we can refine it. So let's go in here. So as I showed you, we had the parameter for scale, where we could choose from a menu if we want to have random scale or if we want to have more control and set it by hand. So this was this parameter, and what we need to do to get the same result. Just a second. We need an enum select uint node. It's here. Let's name the cases random and default. Random and manual. As this is the node that is responsible for the random values, we input this result to the random input of the enum select uint node. We can expose the case, and let's call it scale type. So this is where we get our drop-down menu from. Then we can also drag from a connection from this Y of the makeUvec2 node and name it scale. We can just input it into the manual input of the enum select uint. This goes here. Actually, we need to take this and connect the enum select uint to the X and Y. So now if let's first go to scale and set a range, or change the control type to slider. Let's adjust the range from 1 to 5. So now as the scale type is set to random, it takes the input from the random and gives it to the makeUvec2 node. But when we select manual, it actually uses this one, so we can set it by hand. As you can see, we can scale our fractal sun noise by hand now. So when we save this and go to our graph, you can see that we have the scale type exposed, and we can set it to random and manual. So as before, random is a random value, and the manual, we can use the scale in parameter here and set it by hand. When we choose random, this parameter does nothing. So now we want to hide the scale parameter, and what we need to do is we need to use visibility expressions. So we go back to the randomware tutorial graph. Let's select the scale parameter and go to the graph variable editor. And here we have different settings and fields like this visibility expression field. And for the visibility expression, we have many possibilities to set a condition or statement. It's a bit easier when working with uints compared to when working with floats. So I'm not gonna go to dig too deep into this, but we'll focus on the uint parameters. So basically when we have a dropdown with different values and we want to, like in this example, have the scale parameter only visible when we choose manual, we need to select the scale parameter and, as mentioned, go to the graph variable editor and type in scale type equals 1. So this parameter will now be only visible depending on what's selected in this dropdown in the scale type. So this scale type refers to the scale type dropdown, and the manual option is defined as 1, whereas random would be defined as 0. So if we have a list with more parameters, it always starts at 0, manual would be 1, xxx would be 2, and so on. So as we now defined the visibility expression, the scale parameter will only be visible when we set the scale type to manual. So when we now go back to our element graph and choose the tutorial node, you can see that the scale parameter isn't visible, but when we set the scale type to manual, it becomes available and we can adjust it. So we are no longer using the random values, but can adjust the scale by hand. And yeah, we can use the visibility expressions as well on floats and other parameter types. But yeah, as I mentioned, I won't go too deep into this because I think the tutorial is complicated enough for now. But when you want to know more about this, just let me know and I'll make a tutorial about this as well. So yeah, I think we are ready. We created our first nPass graph, our first self-repeating node. And we could go in and use more nodes and effects to make it even more random, but I think for this one it's enough. So as you can see in the original node, I made a bit more. But yeah, I think you know how it works now and can create your own self-repeating nodes. So I think that that's it for today, and I hope you liked it and could learn something. So let me know what you think in the comments below. And for the next video, I think I will cover layering, so you will learn how to texture your assets and it will be more artist friendly again. So hope you liked it and see you next time.